Okay, Algebra 2. We're going to start right in with Unit 2, Day 1 notes. All right, this is all about relations and functions. You remember from Algebra 1, lots about functions. A little review. Hopefully, you remember some of it. We'll see. Some things I filled in already for you. A relation is just a set of ordered pairs. All right, could be like 1, 2, 2, 3, 3, 4. All right, remember the set of those squiggly brackets makes it a set. Domain and range, you're going to see those a little bit, right? Especially this first part of this year. Domain is a set of all possible x values. Range is a set of all possible y values. I don't remember what these bubbles are for. It's not really important. Lots of examples, though, so we'll get this down here in a minute. All right, state the domain and range of the following set of ordered pairs. So anything that's an x-coordinate is a domain value. So you just got to make a list of them. All right, if you put the squiggly brackets, now it's a set. So you got 1, 2, you got 1 again. You don't have to list it twice. It's already there. And 7. So there's my domain for this example. The range is just the y coordinates. So 2, 3, 5, and 10. All right. So anytime you have ordered pairs, a list of them, that's a relation. Doesn't have to be a function yet, just a relation. All right, it kind of says that here. In a relation, an element in the domain may correspond to more than one element in the range. Some of you may be thinking of the definition of a function. We'll get to that in a minute. All right, it's a little bit different. State the domain and range at the bottom. Let you guys try that one. Very easy, just list them out. Where's the good stuff? Next page. These bubbles, right? Different ways of representing these relations. I think it's supposed to be a 3 in here. Got lost somewhere. So you got 2, 3, 4. This is like your x, or your domain in this case. This is your y. All right. The arrows got messed up. But yeah, your domain is any x. So if your domain, sometimes you just got to list it. The domain is 2, 3, 4. The range, these arrows are kind of out of whack, looks like, but looks like they're supposed to be all have an arrow to them, so we'll list them all. 1, 2, 3, 4. All right, you know this is the x, this is the y, because the arrows are pointing to the right. A little bit more to it, though. Algebra 2, you're going to see equations. You won't see many bubbles or stuff like that anymore. Number 3 is a better question. Says state the domain and range using interval notation. So some more review. Maybe you haven't seen this in a while. First of all, what does this all mean? This is the set of x, y such that y equals 5 minus x. It's a fancy way to write this out. The only thing you really care about is this right here. Y equals 5 minus x. All right, what's that look like? It's just a line. All right, so maybe in the picture, I don't know, put it in calculator if you want. It's just a line, negative slope. All right, and then it looks something like this. All right, so if you're on graph paper, close enough, there's my line. There's my graph paper. Think about the domain and range. Let's just do D for domain. What are all the possible x values? Basically, is there anything that I can't use on that line? All right, remember this is your x-axis. All right, that line goes on forever, left to right. Obviously, it's slanted a little bit, but it's all right. So I would say anything works. So your domain is going to be everything. Negative infinity to positive infinity. All right, interval notation. This is like parentheses and brackets, all that good stuff. You may have forgotten that since Algebra 1. Intervals usually have brackets if it's a number, if it's including that number. It's parentheses if it does not include that number. Here we just have infinity signs, and they're actually not really numbers, so we just put parentheses on both of them. All right, the range for this one. The range is possible y values. So how far up and how far down does this graph go? Eventually that's going to go up further and further and further. This is going to go down further and further, so it's going to use everything. All right, it goes all the way up and down the y-axis. All right, so your range is the same thing. Not very exciting. This one's negative infinity to infinity. All right, parentheses on both. Number 4 is a little bit different. The set of x, y such that y equals x squared. Again, the only thing you really care about is right here. This is y equals x squared. If you remember what that is, it's just a parabola. All right, you can graph it. Just think about it, same thing. Parabola looks something like that, right? And there's your x, y axes. Rough sketch. What's your domain range for this one? So your domain is possible x values. The best way to think about it is how far to the left and how far to the right does your graph go. All right, how far to the left is that going to get? Eventually it gets wider and wider, right? This parabola at the top. So it's going to go all the way to the left. I'm going to say that's negative infinity. And then it's going to get even wider to the right also, to infinity on the right. So the domain is everything, just like the last question. The range, a little bit different though. Range is possible y values. How far down, how far up does this graph go? Well, this one doesn't go into anything below the x-axis. All right, the arrows will point up though, so it keeps going higher and higher. So if it doesn't go below the x-axis, I can say it goes down to 0. All right, it doesn't go below 0, but it does touch 0. So I can put bracket on 0, and it goes all the way up, so to infinity. Some of these pictures, if you don't have the packet, they're gonna be hard to see even on here probably. 5 through 8, I can try to do one of these. All right, so this one has open circles, you can hardly see that on there. All right, open circles here and here. It wants us to find the domain and range for all these. So what is the domain? What is the range? Keep thinking to yourself, if I'm looking for domain, I'm looking at how far to the left, how far to the right does this graph go? So to the left, I go to -2. To the right, I go to 4. So from -2 to 4. And since these are open circles, it's not actually at -2 or 4. It's close to it though. All right. Biggest mistake you see people do is, oh, it goes to -1 and you put a bracket. But don't forget there's like -1.5, right? All the decimals in between -1 and -2. So you need the parenthesis there. The range, this one, how far down, how far up? Because range is y values, right? So how far down does this go? Looks like a -4. And how far up? At 5. So from -4 to 5, open circles, parentheses. Do one more, number 6, I guess. Hard to see. You got open circle here, closed circle, open circle. So number 6, what's the domain and range again? A little more practice. Domain, how far to the left, how far to the right? So people mislead this one, right? So if there's a top, right? Doesn't matter how top it is. How far left does it go? Right here's the furthest point to the left at -5. It's a closed circle, all right? How far to the right does it go? Not this one, but right there's the most extreme right. That's at 4. So a -5 to 4. Closed circle is a bracket. And the 4 looks like an open circle, I guess. That's parenthesis. All right, it's all the interval notation, brackets and parentheses stuff. For this one, what's the range? How far down does it go? Goes down to -3. Right, you're not looking where it crosses the y-axis, but how far down does that picture go? -3 up to 4. So -3 to 4. Looks like an open circle on both, so parentheses on both. All right, let's try number 7. Looks like open circles here, here, closed circle here. Number 8 is a parabola. It's supposed to have arrows on it. These are the worst pictures. All right, give those two a shot. Let's see what you get. We'll go over that next time. All right, more examples. Domain and range. It goes on forever. I guess the scale here is 1, so well, there's 1, 2. This would be at 3. Let you guys find the domain and range of that one. All right, try number 9. You can try 10 too if you want. Try that one. All right, there's the good stuff. Number 11. Number 11 is like an algebra 2 question. State the domain of this thing. X plus 6 over x minus 1. All right, maybe you want to graph it. I don't know. It's up to you. All right, you could try to graph it. Look at the picture. Look at the table all day long. It takes a while. All right, eventually if you scroll down the table, maybe we'll do this during class when we go over this, but you're going to see there's an error message somewhere. All right. Way back when you learned about fractions. Fractions in math have rules, right? You can't divide by 0. You've heard that before. And this is a fraction. So restrictions for fractions, you cannot divide by 0. So if I were to put a number in this denominator, what would make this undefined is what you want to be thinking, right? Because domains are possible x values. There's an x value that makes this undefined. Hopefully you realize that if I put a 1 right here, 1 minus 1 makes a 0. You can't divide by 0. So you could say for your domain, you could say A different way of writing. Let's try this. This is x such that x cannot equal 1. All right, that's that set builder notation. Haven't seen that in a while. All right, so x cannot equal 1. If you're going to do it in interval notation, you could say negative infinity up until 1 works. And then maybe union that together. It's called the union symbol. We're going to say from 1 to infinity works. Looks weird, but this just means everything but 1 works. All right, we don't worry about the range right now, just domain. So that's tricky, right? So you have to recognize it's a fraction. What kind of restrictions do they have? Number 12 is even more tricky, I guess. I don't think you've done this much before. This one has a radical in the denominator. So not only is it a fraction, but it also has a radical in there. Radicals have restrictions as well. You can't have a negative under a radical. So we'll do more of this with a calculator later on, but you can't divide by 0 like we did up here. You also can't have a negative under this radical. So I know this x minus 6 has got to be greater than 0. All right. Otherwise, I have a negative under the radical. Can't have it. It can't be equal to 0 either, because then it's a 0 in the denominator, which can't have. So I know x minus 6 has got to be greater than 0. So that means, let's say we solve for x real quick. Means any x that I use for this question, x has got to be greater than 6. All right, that's essentially your domain. So your domain is 6 to infinity. Anything greater than 6, right? But not equal to, so parenthesis. We'll do more of those. We'll talk about that a little bit more in class. Number 13, state the range, so possible y values. Everyone wants the range. I would just say graph it, all right? Graph it, look at the picture. How far down, how far up does that go? Try that one on the calculator if you have one, hopefully. The last part of the notes, all right, that was just all relations, domains, ranges, all that good stuff. The last part goes into actual functions, right? Functions you did in Algebra 1, function notation, all the f of x stuff. You might have forgotten about it, that's okay. Fancy definition for function, each input has only one output, or each x has only one y, short way of saying that, whatever. Your independent, dependent variables, right? If it's independent, that's your x, dependent is your y. Some examples on the next page, a little review here. Which of the following are functions? So the definition says each x has one y, right? So I can look at number 1. There's an x coordinate. 1 goes to 1, negative 1 goes to 1, 2 goes to 4, negative 2 goes to 4, 0 goes to 0, I guess. All right, basically, if you were to plot all those points, does each x go to 1y? I don't see any repeats in here, so I would say yes, this is a function. All right, so it's just a yes or no right now. Yes, that is a function. Number 2 has these bubbles again, like that Algebra 1 thing. 0 goes to 0, right? 1 goes to 1, negative 1 goes to 1. Instead of these bubbles, you can write those as ordered pairs. That's 0, 0. That's 1, 1, and negative 1, 1. All right, some of you jumped the gun and let's say you see these 2 arrows, you say, no, that's not a function. Right, but does each x have one y? They do, right? So maybe these x's share a y, but they each have one y. So we're okay with that, that works. I would say yes on this one also. Number 3 though, a little bit different. 0, 0, 1, 1, 1, negative 1, 4, 2, 4, negative 2. So right here is something different. 4 goes to 2, 4 also goes to negative 2. All right, some of you had Giovanco back in the day, taking the girl to the party, the dance there and whatever. Same idea. You remember that? That's good. This one's a no, right? This x has 2 different y's. Number 4, keep cruising through these. Fancy way of writing this, any set x, y such that y equals 3x minus 1. Again, right here is all you really need to worry about. Y equals 3x minus 1. That's a line. All right, looks like this. Close enough. All right, is that a function? Does each x have one y? If you were to graph it, it looks something like that maybe. There's my x, there's my y-axis. All right, each x, so if I went to this point, this x right here, it has one y, right? Each x, this x has one y. I would say yes, that's a function. right? Everything's a line usually is, except for vertical lines. The number 5, you haven't seen this much before. Maybe you have in geometry, actually. Any point x, y such that x squared plus y minus 2 squared is 36. This is actually a circle. If you graph a circle, is that a function? Doesn't matter where it is, all right? We'll talk about that later on, but there's a circle. All right, some of you are already saying no, hopefully. Like this is an x point right here, right? This has a y up here, it has a y down here. Can't have that, right? That x has 2 different y's, that's not a function. All right, the next part, easy way to tell that without all that thinking, if you thought at all. What test can we use? You all remember the vertical line test? Vertical line test. All right, anywhere you draw a vertical line on your picture, if it crosses more than once, it is not a function. Like this circle, right? You draw a vertical line, crosses twice, not a function. You draw a vertical line here, only crosses once, that is a function. It's yes, all right? Easy test to determine if it's a function or not. There's a few examples on the last page. All right, lots of notes, holy moly. All right, determine which of the following are their functions. So just yes or no. Here's the line y equals 2. All right, draw a vertical line on it. Use your pen if you want to. Does your pen or pencil only cross once? All right, so no matter where you draw it, only crosses once. That's a yes. Anywhere you draw a vertical line, if it crosses more than once, not a function. Let you guys try these last 3 or 4 here, last 4. Try those, give it a shot. That is day 1 notes of chapter 2 now, all right?